Welcome to this walkthrough base rule lesson from Udacity Machine Learning Nanodegree. And it's saying here's a population, and it is estimated that only 1% of the population has a specific type of cancer. So this can be done by like survey studies, statisticians come up with an estimate. And the overall population is always 100%. So that's like the one we're talking about. In probability analysis, a lot of times we have like a sum equals to 1. So this is 100%, and this is just 1% of that. So it's kind of small. And then usually you're given two stats about a specific test. And some tests are more accurate, some tests are less accurate, but it's usually measured by sensitivity and specificity. So sensitivity is saying, okay, if I have cancer, how likely is this? So say if I'm doing a control study, I already know I have this cancer. How likely is this test going to tell me that I actually do have cancer? Well, that is 90%. So this is a pretty good test. But some people may argue, well, 10% of the time it would have failed to screen for cancer. And that does happen in reality. That's a limitation of our science sometimes. Okay, so it's really 90% of this small circle, which is 1% of this big circle. So it's really 0.009%, 0.009, so 0.9% of the overall population. And then you are usually given the specificity of the test. It's saying how many percentage of the people who do not have cancer will be tested negative. So that's really important. If I don't have cancer, don't scare me, don't test me positive and make me freak out, right? So it's 90% of that. But however, because the overall population is so large, 1 minus 90, literally 10% of that, a large population will actually be test positive, even if they don't have cancer. And the rest of these area not covered is testing negative while not having cancer, right? Because they don't have cancer. We only know people in this little tiny circle behind this 90%, let me remove that. Only this tiny circle have cancer, right? And then the majority of that actually don't have cancer. And this is an area where they will be tested positive even if they don't have cancer. So this is when it's a false positive. Okay, so that's the first setup of the analysis. So let's put some tags here. And this belongs to this circle. So just a reminder, when we do statistical analysis, we're always trying to understand the overall population. And the population, in theory, is known, right, as 100%. And we theoretically, we know exactly about everyone in our population. But in reality, that is not true. That's why statistical analysis is needed to analyze all kinds of probabilities, because the true population can only be studied, but the truth cannot be known.